So today we're going to talk about DIJKSTRA algorithm. So in DIJKSTRA, the D is basically silent. As far as I know, that's what we have been taught in our colleges and even in the classes that I've attended, even from the books that I've read. I think it's just only. But correct me if I'm wrong if it is pronounced like DIJKSTRA or something like that. But I'll just throughout this video, I'm going to pronounce this DIJKSTRA. So today we're going to explore one of the most important, let's just say most popular algorithm in finding shortest paths in graph, GISTRA algorithm. Whether you're navigating maps or designing a network, this algorithm is essential for finding the shortest route between 2 points. So let's just break it down. What exactly is GISTRA algorithm? Let's just take the brief understanding of the definition. So GISTRA algorithm is a greedy algorithm used to find the shortest path from the source node to all the other nodes in the graph with a negative edge ways. So the algorithm prioritizes visiting nodes that are closest to the source and continually update the shortest known distance to each node. That's what the GISTRA algorithm does. It basically is considered to be the greedy algorithm because it finds out the shortest path from the current state to the goal state. And that's what it does, right? So basically, how does it actually even work? So GISTRA algorithm works by maintaining a set of nodes in which the shortest path is known, right? It is also known as the shortest known distance to each node, updating this distance as it finds shorter paths. So what is the basic process of it? So there are 4 steps to it. Assign the distance of 0 to the starting node and infinity to all the other nodes. Then add the starting node to the priority queue. Third one is, while the priority queue is not empty, dequeue the node with the smallest distance for each of its neighbor. Calculate the tentative distance through the current node. If this distance is smaller than the current node distance, update it and add the neighbor to the priority queue. And then repeat the process until all the nodes are processed. This is what the 4 step basic process of GISTRA algorithm looks like, or IGISTRA, whatever it is in the pronunciation terms. So now comes the pseudocode. So you can see the pseudocode of how exactly we're going to code this. So you can just pause the video and can read this entire pseudocode so that you can understand what we are going to be coding. So we're just going to transform this or translate this into Python programming language. Apart from that, it's exactly the same that we're going to do. If you take the pseudocode and take it to the process part, like the recent part that we did of understanding what exactly is process. So process to pseudocode to Python programming language. If you do it step by step, then it's too damn easy to execute. If you just jump directly into coding, then it sounds hard, it seems hard, it even looks or even feels hard if you try to do that. But I usually do. I do the process, I do the pseudocode, and then I write the code. And that makes it really, really easy, like the piece of cake. So let's now move on to our coding screen and write some code. All right. So the first thing that we do is import heap. So it's heap q or it's hard really. Python uses these weird words to even as variables, even as functions, even in libraries it uses weird names. Don't you just simply name is heap or heap? What is the heap peak, whatever this is? So then registra or digistra, whatever it is, graph, then start. So we're going to initialize the distance and the priority queue. And how do we do that? Creating distance as a first list, normalize the list. It's basically set 100. Yeah, 0, the priority queue equals to 0 to the start. Okay, it's kind of easy. Now we'll create a while loop, and inside of while loop we are going to assign the current distance and the current node to heap dot heap pop and priority queue. So this will basically hold both the values of the current distance and current node, whatever value we get from using the function of heap heap pop from of priority queue. So whatever answer we get, the first thing will be assigned to the current distance and then the current node. Then we'll skip the process for the shortest path has been already found. If you find the shortest path, then skip the entire process. Genuinely skip the entire process and just do the if stuff. So if current distance is smaller than the distance of the current node, then continue. And what is there? Then we have a for loop for exploring neighbors. So if your current path is not the shortest path, then you have to explore all of the neighbors, right? So to explore neighbors, we are gonna do this stuff. And once you go along and exploring the neighbors, if the shortest path to the neighbor is found, then update it, right? Okay, he push priority queue distance neighbor. All right, distance and neighbor. And once we're done with that, we'll just return distances, right? It's pretty simple. All right, so once you're done with returning these entire stuff, now we are good to create our um agency list. Agency list. So basically in this one, we'll be doing like creating a simple agency list, which will include offsets, a set of it. Small little tons of them. Like the A have B and C, and then B has A in 1 and C in 2 and D in 5, because it has okay, that's kind of a little bit confusing. So just go along and just try this, or let's just say put it on Google, or maybe write it in ChatGPT and just make it try to have it as a visual format, because in visual format it seems really clear and seems really understandable once you do it visually. When you write these codes, it seems pretty complicated, but once you do it like in visual formats, it seems and makes a lot of sense. Right, so we're gonna make some tiny bit of changes. Then the start node will be basically A, and then we're just going to discover the shortest path. So I'll just simply, just for fun, write shortest distance from node A. Right, then we're going to declare a variable calling it distances, and then digstra, 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 pass on graph and the start node, and then print distances. So once you do that, you will actually get an interesting output. So the output shall pretty much look like A, B, C, and D, 0, 1, 3, 4. That's what it should look like. Okay, it returns some kind of error. I think it says items, and there shall not be items. Okay, items are not supposed to be here. So I think it's pretty much completed. Let's just run this once again and see if we're done with that, and we are done. So you can see we got the output 0, 1, 3, 4, as I said we are supposed to get. And this is where our DIJKSTRA algorithm is over. Thanks for watching this one. So if you like the video, put on like. If you dislike the video, don't like the video and dislike the video. So subscribe to the channel to get more content like this. Till then, keep watching. Code with